Everyone, can you guys hear us?
I can hear you guys.
All right, great. It would be really great if you guys can turn on your cameras. All right, welcome. Hello, Lloyd. How are you doing?
Good.
All right. We have a pretty fair amount of people, so we're just gonna start now. Hey, everyone. Welcome to the Inland Empire Math Circle. Today is our first meet, and today we will talking about the Towers of Hanoi. So, let me share my screen real quick. Oh, and by the way, I'm Hambo, and this is Eric. You can see his name right there.
Hello.
And we will be the main instructors for you guys today.
Okay, hello guys. Can you see the screen share? It's three rods A, B, C, and the two little ring things here. Can you see that?
So basically, the rules is, well, the goal is that you want to move all the rings on the first peg, peg A, onto peg C. And basically the rule is you cannot move a larger ring on top of a smaller ring. Eric, you want to demonstrate what that looks
Yeah,
like?
so for example, the purple ring is on B, but if you put this like sort of blue one on top, it doesn't work. It doesn't allow it because it is a bigger than that. But in contrast, if you put the purple ring on top of the blue ring, that is allowed because the purple ring is smaller than the blue ring.
Does that make sense to everyone? Okay, sounds good.
Cool.
So why don't we start with two rings of the Towers of Hanoi? So do you guys have any idea like how would you move it so that it's on C? Oh, and Kimmy, do you have a question?
I was thinking of like the answer.
Oh, you have the answer? Yeah, go ahead. Go
Oh,
ahead.
cool. All right.
First put the purple ring into the B spot,
Okay.
and then put the blue ring into the C spot, and then the purple ring back to the C spot.
Good. All right, just for sake of keeping track, I'm gonna write how many steps we took for each case. So for two rings, we have 3 steps. All right, let's check out what happens when we have 3 rings.
All right.
Kimmy, you have an idea of how to do this?
Blue one to B, C to A. Wait, no, B to
Maybe
A.
you wanna.
Wait.
Yeah,
B
maybe
to A.
reconsider.
Yeah, remember you want to move the green one on the bottom from A to C.
Can I
Because,
think of it right now?
yeah.
Just look at notice how peg C right now has a purple rim, right? So you want to move the green one to peg C, but right now there's something blocking it. So what do you think is the best possible way to deal with this?
I got it. C to B,
Yep.
A to C, purple ring to B, purple ring to A, actually, B ring to C, A ring to C.
Good job. You got it. Eric, why don't we let him try the 4 rings?
All right.
All right, Lloyd, let's give it a try.
Move the purple wing to the B. The blue ring to the C. The B ring to the C. The A ring to the B. The B ring to the A. The purple ring to the B. The blue ring to the A. And the B ring to the A.
Lloyd, you have the right idea here, but basically we want to move the rings from A to C. So you might want to switch what you just did around so that you end up with all the rings on C. Do you want to give it another try?
Okay. The purple ring to the B. The blue ring to the C. The purple ring to the C. The green ring to the B.
We could move the purple ring
The
somewhere.
purple ring to the purple ring to the A.
Yeah.
This the C ring to the B. The purple ring to the B. The A ring to the C. The purple ring to the A. The blue ring to the C. The A ring to the A ring to the C. The purple ring to the A.
Hey, look, I think we might want to backtrack a bit here because you see, you want to move the green on top of the yellow, right? And right now you have a blue. So like the first couple of steps of your idea was right, but let's undo a couple of steps and see what we can do otherwise. Yeah, so Lloyd, do you think there's a better way so that we can move the green to yellow?
You can move the purple to the A. You can move the
Maybe we should try, instead of moving the purple to A, maybe we should try to move it to C. Maybe we should see what happens then.
You can move the blue to the A. And the C to the A. And then the B to the C. And then the purple to the B. The A to the C. And the B to the C.
Good job. You got it.
Good.
Hey, Kathy and Ming, do you guys want to try the case with 5 rings? Can you guys hear us? Kathy and Ming, you guys might be muted.
Yeah, I can.
Oh, okay. All right, Eric, let's give Kathy a go at 5 rings.
Um, purple ring to C. Blue ring to B. Wait, actually, um, purple ring to B. Green ring to C. Purple ring to C. Wait, purple ring to A. Blue ring to C. Purple ring to C. Yellow ring to B. Purple ring to C. Wait, no.
Try moving the purple into B. Do you think that works?
Yeah,
Give it a try.
yeah, and then blue.
You're getting it.
Blue ring to A. Purple. Purple ring to A. Green ring to B. Blue ring to B. I mean,
Huh.
purple ring to B. Purple ring to C. Blue ring to B. Purple ring to B. Orange ring to C. Purple ring to A. Blue ring to C. Purple ring to C. Green ring to A. Purple ring to A. Wait, no. Wait. It should be blue ring that's going to. The purple ring go to B. Blue ring to A. Purple ring to A. Yellow ring to C. Purple ring to B. Blue ring to C.
Hey, Kathy, just real quick, a thought. You want to move the green ring to C, right? So
Yeah.
like right now, when you move purple to B, it's like you have to move the blue ring to C, so it's blocking the green ring. Maybe try moving the purple ring to C and see what happens.
Oh yeah. Blue ring to B. Purple ring to C. I mean purple ring to B. Green ring to C. Purple ring to A. Blue ring to C. And purple ring to C.
Good job, you got it. All right, so I think we should take a bit of a pause and see if you guys notice any patterns in the numbers here. The numbers I wrote on the left side of the screen. Kathy, I see a thumbs up though. Do you have an idea?
Is it going by. Wait a minute. Never mind.
Does anyone else have an idea? Kimmy, Loy, Yuan, Ming? Have an idea?
It looks kind of really related, but like I just can't figure it out because every time it adds, it's not like it adds the same number.
Okay. So
Yeah,
so you
maybe.
wait.
Yeah, go ahead. Go ahead.
Um. Yeah.
Yeah,
Go
go ahead,
ahead.
Eric.
Okay. So you're on the correct idea, but why don't we look at the differences between each of these numbers. So between 2 and 3, we have 4. So because 7 minus 3 is 4, right? Like you're looking at the differences between all of these numbers. But if we look at between 3 and 4, it's 8. And if we look at between 4 and 5, it's 16. So now do you notice a pattern?
Yes, the numbers double.
Yeah. So now you might wonder, like, why is that? But it's not only do the numbers double, but you can also notice that there is a relationship between, say, this number and this number, this number and this number.
The lines I'm drawing here might help you guys.
Yep.
Notice how the numbers on the right and the left are related.
So if we would do a sixth ring, then it'll be 32.
So
I'm not sure about that. Maybe check it in.
yeah, so look.
Because like 16, it's 15 plus every one of the number. Wait, never mind. I can't see this.
So I think you're on the right track here. So you notice that the difference between 4 and 5 is 1 plus the value, like the number of turns that you need for 4. So 4, it takes 15 sort of like movements, and 5 takes 31, and the difference is 16. So you did notice that 15 plus 1 is 16, 7 plus 8 is 8. Is that 7 plus 1 is 8, right? So you are on the right track here, but notice how the blue ones are actually the differences, not the actual number of moves, correct?
I see now.
Yeah. So what would you say, what would you think 6 would actually be?
Lloyd, Kathy, Ming, do you guys have an idea?
63.
That is correct. Let me write that down real quick. So 6, we would be having 63.
Yeah, because the difference between 5 and 6 would be 32, right? Since you look at this pattern, and if you add 32 to 31, it would be 63. So how would you guys sort of generalize this idea, right? Like we have all of these numbers, but how would we sort of generalize the idea, the relationship between 2 and 3, 3 and 4, and 4 and 5? How would you generalize so that we can keep on finding it over and over again?
Something that might help you guys is notice the relationship between each of these numbers. Notice how 7 is 3 times 2 and plus something else. And 15 is also a little bit more than 7 times 2. And 31 is a little bit more than 15 times 2.
Yeah, go.
Do you have an idea? You might be muted.
Oh, wait.
No idea.
Oh, okay. So if we have you guys learned a bit of algebra yet? Like,
Yes.
yeah, like letters, right? So
Yeah.
if we represent, say, 2 with n, like if we say the current one, if we call it if this n, so n could be 2, 3, 4, or 5. But what would we say sort of the next one would be? If we say the next one, let's call it m, right? So m equals something of n. So what would you say the next one would be based on n? So notice how the difference between them is n plus a number. So the difference between 2 and 3 is 4, and 2 is 3. So have you noticed that there's a relationship between the difference and the previous sort of number of moves?
I think it would help you guys to look at this with an eye towards multiplication instead of just pure addition, because notice how 7 is just a little bit more than double of 3, like 2 times 3 plus 1 is 7. And notice how 15 is just 2 times 7 plus 1. And notice how 31 is double of 15 and then plus 1. Do you guys see the pattern?
I think I get it.
Yeah, so what is it?
So n is 2 n's plus 1.
Bingo. Yep, Kimmy got the pattern. So everyone, in case you still don't quite understand, basically the pattern we've got here is that the amount of steps you need for m rings is exactly 2n plus 1, where n is the previous case. So for example, since the case with 4 rings has 15 steps, then that would mean that the case with 5 rings needs 2 times 15 plus 1 steps, which is 31 steps, as we found out. So does that make sense to everyone? Loy, Kimmy, Kathy, Ming, you guys got it? You got it?
Yep.
All right. So now that we found the pattern, does anyone want to try to guess at why this pattern exists? Yuan, Kimmy,
Can I ask
Loy.
a question?
Go ahead, go ahead.
I think the 5 rings 31 might be not exactly be the shortest amount of moves.
Oh, why do you think that?
Like third, it's like you could see that 3 jumps to 7. That's 4. That's not really a lot. Like that, it makes sense because there's new rings, so you gotta have more time to figure this out. But like, why would it from 15 to suddenly jump to 31?
So actually, that's actually a perfect transition into why this happens. So if we replay the 5 ring scenario, we can actually see that one of the first things that you have to do is to create a 4 ring tower, right? So we have to create a 4 ring tower on B before we can move this final orange one to C. So actually it would take this, we would have to first produce a 4 ring tower. So that actually does kind of make sense because you have to make this 4 ring tower, it would already take a lot of moves. So the difference would be even more, since after you move the orange ring, you have to build that again, right? So that is actually why it increases so much every time. That makes sense?
I get it.
Yeah.
So with Eric's explanation, does anyone want to take like a guess at the explanation for why it's 2n plus 1? Like why the general pattern is 2n plus 1? Loy, do you want to go ahead and take a shot?
You know where the 2n comes from? First in the equation?
Yeah.
Remember how we have to move the stack of 4 rings? So that takes 15 moves. You have to move it to B. And then we have to move it back to C on top of the orange ring.
Yeah, nice.
So you have to move the rings of 4 2 times, right? So that'd be 2 times 15. But we also have to move the orange ring from A to C here.
So basically there are 3 sort of sections, if you will, of the sort of like of this movement. So the first section is moving it from, all right, so moving these 4 rings from A to B, right? And then the second section is moving it from A to C. And then the third section is where you move just the final, like those 4 rings from B to C. And that is how you actually solve this puzzle. So we can see that like how long would the first section be for moving for in this case a 5, for moving these 4 on top to this on B? Like how long would you think that, how many moves would you think that would take? Since we have this little chart here.
It's 15.
Yeah, very good. Yeah, it's basically like it's almost like a subcase, and we're just basically doing the problem with 4 rings first, and then we're moving the orange rings.
Yeah. So then how many moves would you say the second section would take, moving this orange ring to C?
That'd only be one move.
Yeah, of
Yep.
course it would only be one move. But then the final section, how long would you say moving it from B to C would be?
Probably another 15.
Yeah, so if we look at this, then we get, so since,
I get it. 15
yeah, so
plus
it would,
15 is 30, and then plus 1 equals 31.
yeah, so that's how we see that.
Oh,
But if we
for those
go,
of you wondering, for some reason, we started up with 3 moves. So the 34 should actually be 31 because we actually, like the program started with 3 moves. So we actually took 31 moves.
oh yeah, sorry, there was a bit of a bug in the system.
Yeah, so does everyone get what we're trying to hint at? So basically, to solve those kind of problems, you basically want to first move the top rings except the bottom ring to peg B, and then you move the bottom ring to C, and then you move everything else back onto C. So it's almost like the previous case with one less ring, you do that 2 times, and then you add an extra step because you want to move the bottom ring to C, which is why the pattern is 2n plus 1. So does that make sense to everyone?
Oh yeah.
Does
Mhm.
anyone have any questions?
Nope.
Oh yeah, and by the way, this sort of idea is actually very helpful for figuring out which rings, which sort of peg you want to move first. Because when you have all of these rings, it's kind of hard to figure out where you want to first move that purple ring, right? Do you want to move it here or do you want to move it here? But if we actually look at that, if we look at say 3, then we can actually see that we want to first build this ring here, this tower of 2 on B. So that means that in order to build a tower of 2 on B, you have to first build a tower of 1 on C. So if we have a tower of 1 on C, then that means that we have to start the purple one on C. So if you notice that, well, actually, let's look at one ring. So if we have one ring, then we have to just move it to C. And we don't need to establish a tower on B. But if we have 2 rings, then we have to establish like this sort of other tower on B and then on B. So what this sort of means is that for number 1, for if you have 1 ring, you want to first move, right, okay, wait. But if you have 3, then you want to first establish this tower in B. So you have to always move it to C like that, so that you can actually first build this tower. And if you have 4 rings, then you actually, instead, you have to put it on B, because if you establish this sort of green base tower on B, then you can move it to C, from the yellow one from A to C, right? But because you have to build this on C, this 2 tower here, then you have to put this green here. That means that for this one, you have to put the green one on the purple one on B first. So what this actually means is that if there's an odd number of rings, you have to first move the purple one to C. But if there is an even number of rings, you have to move it onto B. Yeah, it's a little complicated, but that's sort of the idea, part of an algorithm for solving this. Yeah. All right. All right, so why is Campbell not there? Okay, so now we will move on to another sort of interesting scenario, which is using multi-rings. So here we have 2 purple rings, 2 blue rings, and 2 green rings. So does anyone have an idea on how we can actually solve it like this? Can we? I think you muted yourself.
There's 2 rings on each one of them, so we can stack the purple rings together, right?
Yeah.
So I would just say it's the same, but just that it's gonna be doubled. So that with three of these, with 3 cones, probably there's gonna be 14 moves.
Okay. So yeah, so we can see this.
Yeah, that's a great observation.
Yeah, so we can do the exact same thing as 3, but we just have to do double the moves, right?
Yeah, Eric, why don't you move the reins and
Oh wait.
it's fine. I'll erase the board. Just like
Okay. Yep, and if we do the exact same, we do notice that in fact it is times 2, right? Does everyone understand why? Yep, because it's just you just have to do each move twice, right?
yeah, why don't we to like get a better grasp of it, why don't we do 4 rings? Hey Lloyd, do you wanna try it out? Right, go ahead, Lloyd.
Move the purple ring to the B ring. Move the other purple ring to the B ring. Move the blue rings to the C ring. The B ring, the purple rings to the C's, to the C ring. The green to the B. The other green to the B. The purple one to the A. The other purple one to the A.
You're on the right track. Remember how we wanna create like a smaller tower on peg B first?
The C, this blue to the green. The other blue to the green. The purple rings to the B. The other purple ring to the B.
Can I ask, is there going to be 30 moves?
For this case,
Yes.
uh,
Yeah,
we'll see. We'll see.
we'll see.
Yeah, probably. I think so. Yeah, why don't we let Lloyd finish it and then we'll see what happens.
The yellow rings to the C. The other yellow ring to the C. The purple one to the A. The other one to the A. The purple one to the C.
Yeah, so we can just move it straight to the C.
The blue rings to the A. The purple rings to the A. The green rings to the C. The purple ring to the A. The purple one to the B. The other purple one to the B. The blue ones to the C. The other blue one to the C. And the purple ones to the C.
All right, Kemi, you got it. Good job. And
Yeah,
I
good
mean,
job.
sorry. And then Loy, you got it. Good job. And Kemi, your observation is correct. It is indeed 30. Do you want to give an explanation of why you predicted that?
Cause when we did one ring, like only 4 rings, we got 15. So this is basically just double because it's 8 rings. So it's basically just 15 times 2.
You got it. So does everyone understand what Kimmy just said? It's basically just the idea that it's with Turing's, it's basically the exact same thing as when we had the normal Towers of Hanoi, except now we have to do everything 2 times because we have Turing's. Does anyone have any questions? All right, in that case, Eric, why don't we move on to the next exploration?
So let's actually have a look at, because we have 3 pegs right now, and we've only looked at rings. How about we actually look at the number of, sorry. Oh, wait.
That's
There we go.
the second one. Yeah.
Yeah, okay, sorry. So why don't we actually look at the number of pegs? So in this case, we actually have 4 pegs instead of just 3. So why don't we actually look at how we can solve this with 4 pegs? Kathy, yeah?
I think it's easier than like the 3 rings ones.
Yeah, it is easier.
Yeah, so how would you say we can actually solve this?
I got it.
Kathy, go ahead. Go ahead.
Okay, so purple ring to C, blue ring to B, green ring to D, blue ring to D, and purple ring to D.
Great, you got it. And that was pretty straightforward. So why don't we try 4 rings?
All right.
Kimmy, you want to give it a try?
Sure. Purple ring to C. Blue ring to B.
Oh,
Purple ring to B. Blue ring to C.
oh, you mean green ring?
Yeah, green ring.
Yeah, okay.
Purple, yellow ring to D. C ring to D. C to D. Purple to A. B to D. A to D. Wait. Oh, I get it.
Yeah, great, you got it.
Yeah, you got it.
All right, why don't we try one more case with 5 rings? Lloyd, do you want to give it a try?
Okay. The purple ring to C. The blue ring to D.
Sorry, was that B or D?
Hey, Lloyd, I think you might be lagging a bit. Can you hear
Yeah.
us?
Blue ring to the B. blue ring to B, and then the
Lloyd, I think you might be lagging a bit. Why don't you try rejoining?
I have it.
Sure, give it a try.
Can I restart?
Okay.
Purple to C, blue to B, purple to B, green to C, purple to D, blue to C, D to C, yellow to B, A to D, B to D, purple to A, blue to B, C to D, B to D, A to D.
All right. Nice.
You got it. So, do you guys want to try the next case with 6 rings, or do you guys want to try something else? Lloyd, Kemi, do you guys want to go to the next case with higher numbers, or do you want to do a slightly different activity with a different
Can we do
set of
more
numbers?
pegs?
Even
More
more
pegs?
pegs?
All right, sure. Then why don't we give a try at 5 pegs?
Actually, like it's actually kind of interesting because for a lot of increasing pegs, it's actually kind of even like professional mathematicians have trouble to find like a pattern in these sort of like problems. So it's actually quite interesting.
Uh, Basically, the Tower of Hanoi problem with 4 pegs was actually solved in 2014, which is actually 8 years ago. So like, you guys know how we found like a general pattern, like the optimal solution and 2n+1 for 3 pegs? Well, that like the equivalent statement for 4 pegs was actually not discovered until 2014. So when you guys go further in your study of mathematics, maybe one day you'll find the solution for that yourself. But meanwhile, yeah, let's go on to 5 pegs and do some bit of exploration. Lloyd, you want to give it a shot?
Can I ask when does class end?
The class will be ending in 13 minutes at 8 o'clock. Yep, 8 o'clock. Lloyd, you're still lagging a bit. Do you want to type what you just said in the chat? Because your voice is kind of lagging. Okay. He said purple onto C.
Yeah.
Blue ring to D. Because you're green ring to A. I mean, yeah, green ring to E. Uh-huh. 2 more steps. blue to E. And then, of course, we would finish with C to E. Congratulations, Lily, you got it. Hey, you, I see your hand raised. Do you want to give a try at 4 rings? You gotta unmute yourself. All right, hello. Want to go?
Oh god.
Do you want to get the audio to try again? I think that was a bit laggy. Do you want to give it a go?
Yeah.
She wants to give it a go.
I think your audio is kind of lagging. Why don't you do like Loy and type into the chat? So just do something like, you know,
Yeah, she's good now.
Oh, okay. There we go.
okay, you sure, go ahead. Are you there?
Purple to B.
Good job.
Blue to C. Green to D. Yellow to E. Green to D. Green to E. C to E. Purple to E.
Good job. You got it. I think it's actually pretty nice how with like more rings, we actually get more options as it's less steps. Do you guys want to try with one more ring?
I think we should move forward.
Okay.
Okay,
Let
then
us.
why don't we do color pegs?
So the issue with colored pegs is that actually you have to move it from a, so for instance, we have this sort of brown color and this kind of tan color. You have to move between different colors. So this purple one, you actually can't move it to B, like cannot move rings to pegs of the same color. You have to move it to C. So if you want to move the purple from A to B, you have to first move it to C. That's basically the idea.
Does anyone want to give it a try? I see US hand raised. Do you want to go?
Yes.
Okay, so how would you move it?
Um.
Yeah, you there. So just remember that you have to move it to a different color.
Purple to C.
Great job. Continue.
Purple to B.
Nice.
Blue to C. Mm, B to A.
Actually, you can't move the purple from B to A, remember.
What you can do is move it to C and then to A.
Purple to C.
Good job.
Um, Purple to A. C to B. Purple to C. C to B. A to C.
B to C. C to A. B to C. A to C.
Nice.
Good job, you got it. So we have 13 moves. Kimmy, Lloyd, do you guys want to give a try at 4 rings?
I'll try.
Okay.
Purple to C. Purple to B. Blue to C. Purple to C. Wait, redo that. Wait, no, never mind. Purple to A. C to B. Purple to A. Wait, purple to B. Wait, purple to A, then to B.
Yeah. There you go.
Green to C. Purple to A. Oh wait,
So
yeah.
purple to C and then
C,
A.
A. And then B to C and yeah, B to C. Purple to A. Wait,
Yeah.
purple to C. And then to B. And then blue to A. C to C. B to C. Blue to B.
You actually can't move blue to B, even if you move it to C right now.
Then I kind of don't know.
Yeah.
Because
So
I think I got myself into an infinite loop.
yeah. So like the kind of colored pegs is sort of just designed to throw you off. It's sort of just like slightly confusing. But if we just remember like what we did before, right? Like you want to first set up that sort of green, like the 3 tower on B. We have to do the same thing, right? So why don't we try again, but just try to set up a 3 tower on B and just sort of ignore the yellow one.
Purple to C. Blue to B.
I remember we can't make the
Oh yeah, I forgot. Purple to B. Blue to C. Blue to purple to C. Wait, never mind. It's purple to A.
yeah, so purple to A. Good.
Blue to C. Wait,
Oh,
never
blue.
mind. No, not blue to C. Well, yeah, blue to C.
Oh, you mean blue to B?
Blue to B.
Yeah.
Purple to C. Purple to B. And then, oh, I got it. Purple to B, purple to A. Oh, yeah. Purple to C and then A. And then blue to C. Purple to
No,
C. Green to B.
but we can't move green to B, remember?
Oh, okay, I'm stumped.
So why don't we actually go with 3, remember? So if we first build a tower of 2 on A, and then so if we move the green ring to C and we build a tower of 2 on A, then we can actually finally move the green peg to B. So why don't we try that?
Green to C.
All right.
green to C, purple to C, and then to A, B to C, purple to C, I built a 3 tower, but now I don't know what to do with it.
Yeah.
Fine. The class is coming to an end, so we gotta wrap up right now. However, we encourage to keep on exploring this problem, and we actually have a discussion problem for you guys in store for this week, and that is to find the number of moves for 4 rings and 5 rings with color pegs. We will be posting the problem on the question board and on our website with the page called discussion problems. You guys can find the problem there. We will also link the link to this app on the question board page, so you guys can go there to keep on playing around with the Towers of Hanoi. But otherwise, is there any questions?
No.
All right, good job, everyone. You guys did great, and we will be seeing you next week at the exact same time at 7 o'clock. Thanks, everyone.
Bye bye. Thank you.
Thank
Bye.
you.
Thank you.